I thought I'd take a couple of example scripts that I've done in the past to re-upload and redo a video, partially just to make sure that all of my new equipment that I've got is still working or working with my new setup. What has happened is since the last time I ever posted a video, which has been months ago, I actually had a house fire where I lost most of the house. And it is what it is. We're in the process of replacing that house, and in the meantime, I'm mostly working on the behind the scenes of getting that ready. Um, Back in 2020, though, like a lot of people, I was stuck at home and getting a little bored. And whenever the weather wasn't nice and couldn't do things outside, I would do things like whenever I couldn't sleep, that is, I would take little short basic programs from back in the 80s and try to make them work on a modern computer using PyGame and Python. There was a claim back in the 90s, or at least it started in the 90s for me, that Python was the new basic. And that's a little unfair when you consider just how far Python has come since then, but that was the claim at the time. It was a programming language that, unlike most, looked as much like the pseudocode that you would find in a textbook as anything that was out there. And for that reason, I kind of agree, but it's a much different language than BASIC, at least syntactically. Also, modern computers are a lot different than the computers back then. Yeah, here's a dozen lines of a program that all it does is it draws a random colored circle in in a not a spiral, but in a circle itself. And to show you what that looks like, here we go. Run without debugging. Yep, there you go. And essentially, it's a radius of 50 pixels so that one side of the circle is in the center and one side is on the outside. It looks kind of like a spirograph, doesn't it? So here we go. We've got a for loop that does 360 degrees at a step of 10. And then we've got this radius here, I times 3.14 divided by 180, and F is cosine R times 50 plus 160. And G is sine R times 50 plus 100. And then we've got a random color and a circle drawn at point F, G of 50. And then, there you go. And then we wait for keyboard input, and that's it. So you might be thinking, okay, that's a dozen lines, right? Once you get down into the Python script, the script ends at line 81. Now that's a little unfair because, this dozen lines is part of the 81 lines of the code. But even if you take the comments out, you've still got a lot of lines of code, right? Well, part of that is because I'm trying to get something that's roughly the same as the experience of running this on an old computer. So we're having to import PyGame, random, GFX draw, math, PyGame locals. Now, the first concession to newer computers is I am opening a window that has a geometry that is 3 times as large as what I want. That old Tandy that I would have been targeting with this, that's screen 7 would have been 16 color CGA mode, IBM PC Junior compatible. Um, However, if you want that 4:3 aspect ratio, you really want it to be 320 by 240. Here, this one's pretty simple to explain. CGA had a color palette that was more or less just bit flipping, um, except not really. That you had 1, 2, and 3 that would set R, G, and B, and then an intensity was the 4th bit, except that on certain colors, the intensity would have been a little bit different. Like this one is AA5500. That's actually done at the monitor level, as I recall. So the first difference we've got here is I'm setting R in the loop. So I've got for I in range 0, 3, 60, 10, just like in the basic program. And then for R is this. Now you might be wondering what's with the nested parentheses here. The outer one is a it's not a list comprehension. Forgive me. I'm just not going to look it up right now because, like I say, part of this is just making sure my equipment works. It's like a list comprehension, except it does it on the fly. It's a generator. That's it. Assigning F and G is almost identical to the basic program, except, concessions for how Python does it. Color, I'm just picking a random color from this dictionary up here. And then I'm drawing a circle on the surface with a random color with F and G being the origin point and 50 pixel radius and a width of 1. The PyGame circle function can actually draw a variable. You could set it for 3 pixels and it'd be a wider border basically. And it's just a little bit different. And because Python doesn't have end, it just uses indentation. There's no next like there would be in basic. Here's where it gets just the tiniest bit interesting, because I decided on these scripts you can use CRT shaders in PyGame, but they work on some graphics cards and not on others, because the easiest way to do it is to use a library called Modern GL, and it certainly works. I've done it. It actually looks really nice and it looks really authentic. Unfortunately, on my laptop, and until I get an actual dedicated GPU for my desktop, neither of them support Modern GL. So instead, what I've got is in PyGame, there's not a Gaussian blur, but there's a community edition fork. PyGame itself is in what you might call maintenance mode, apparently. They're in a process of transitioning to where the community edition has the changes. Those changes might survive into the next version of PyGame. They might not. If you want the features now, though, you have to use the community edition. So we've got a Gaussian blur of 1 on the surface, and then I do a transform that's known as a smooth scale, which also does some smoothing up to the real resolution of 960 by 720, and we blit that onto the window right here. And then we flip the display to let the user see it, and we update it. And then until somebody hits the quit key or they hit the X on the window, it just stays there. So here we go. We'll do it again. There you go. Having done that, there was this old Compute magazine article back in the day that it came from 1987, August 1987, says it right there. Fractal Mountains for Amiga. Now, I had never had an Amiga. In 1987, at Christmas 1987, my grandma got all the grandkids Tandy 1000 EXs. That's a major gift, of course. But, of course, for somebody who just drooled over the Amiga, it was a little bit of a disappointment. Now, I could have adapted that script to run on a Tandy, and I could have used the color palette that was available. I never did, though. It occurred to me during the pandemic that this thing that I had always wanted to try out, just because I saw it in the magazine and it looked neat, even though there are much better fractal mountain generators now and much more interesting fractal generators on modern computers, I still wanted to try this particular one out. And I thought, I wonder how hard it would be to take Amiga Basic and port that over to Python. And here we go. Here's the script. I will tell you, this was probably done using OCR, optical character recognition, because I found some mistakes in it whenever I was adapting it. One difference between Amiga Basic and other types of Basic of that time is that this is one of the first ones that did not have um, line numbers. Instead, they had labels. Like here we've got make mount. Here we've got do tops, do bottoms, do centers, draw mount, which is draw the mountain. Then there's a subroutine called get shade to get the color. Um, if you've never used Basic, but you have used Python before, a lot of this is going to be recognizable. Some of it not, because the syntax of Basic and Python are a little bit different. But if you've used either language, nothing that I'm going to show you here is going to be especially foreign. One of the things that I had decided, just a constraint to put on myself, was to change as little as I needed to make this script work. And I feel like I succeeded here. So the first thing you have to change, of course, is that you've got to do all these imports for PyGame, random, graphics draw, locals. Date time is there so that I can save files. The original script actually had a feature to save the file, if I can find that real quick. Yeah, here it is. That you can tell it a file name, and if you put in a file name, it will save the image in. I don't remember what file format it is. I think it's the same file format that Deluxe Paint 2 used. Could be wrong about that. But instead here I save it as a PNG if I want to. So one of the things I decided, because Basic tended to use global variables everywhere, was that I wasn't going to use global variables, but instead I used classes or a class to do, global variables anyway. So I'm set up a bunch of the variables that the original program set up. We've got a snow line set to 0. Any elevation in this that's below 0 will be blue. And here we go. The first thing that I ran into in this program that made me scratch my head just a little bit was right about here. Okay, so we've got a equals 0 to 15, and then palette a divided by 15, a divided by 25, a divided by 50, and then blah, 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 blah. Now, in my mind, I know this means that this is a fraction. Now, I've never dealt with that in palette colors before. And that's not how colors work in PyGame, so what's going on here? And then this one's a plus 16, and then this is just a divided by 15. And then there's another one here, then, Anyway, palette 16 is 0.25.5. That's going to be the water. So when I looked it up, the original Amiga 1000 had different color modes. One was a 32 color indexed mode. Another was a 64 color where they use extra bits to set an intensity mode so that it's also called half bright. And then there's one that we don't have to worry about at all that's called hold and modify. But the way it was implemented in Amiga Basic is that they just used fractions, essentially. So the way I resolved this was, because everything's an 8-bit number here on R, G, and B, here's how I resolved that. 16 times A divided by 15. Because I didn't want to change more of the code than I needed to, I slavishly stuck to to this 25, 15, 25, and 50. Um, and then I bit shifted it to make it to convert it from a 4-bit to an 8-bit number, and then added it to itself, because what we're wanting is, like, if the hexadecimal integer of this ends up being A, what we want it for R to be is AA. And you probably saw that over here. The Amiga had, I think it was 12-bit color, and this is 24. So all we really need to do is we need to double this here. So this is RGB, this is A, or 10. Or it's not 10, but anyway. Pardon. And then I've got a function here for get shade. This replaces the go sub that was over here. And then I've got the drawing routine. This is largely unchanged from the original, that we're just doing a for loop where we get increasingly or decreasingly, however you want to put it. It does a smaller iteration on each one. It starts out with like every 6, I want to say. Or no, not every 6. Yeah, it's every 6 or 5. And then it draws in between and draws in between. It's a fractal routine. And we're going to be calculating based on previous numbers and based on a random number, a new level to go in between 2 other levels. Yeah, you'll see in a second. Okay. And here we're calculating slopes and picking a color based on the slope's relation to a noonday sun type of lighting. And then here we use these numbers that we calculate there to draw a polygon with the color that we pick based on the shade. And just like with the Circles program, we've got a Gaussian blur of 1, and then a smooth scale up to 960 by 720, and then all of this. And then how I've got this set up is I've got a loop that it will check to see if you hit an escape key or a Q, and then it'll quit. If you hit S, it'll save an image with a timestamp, and if you hit any other key, it just redraws. So how does that work? We're just going to go ahead and run it without debugging. Every time I hit the space key, it draws a new set of mountains. You can see it's a little blurry. I would really like it if modern GL was more supported by, like, say, laptop hardware, because one of the problems I ran into was, of course, like, I would set it up on my desktop, my old desktop that was in a fire, and it would look beautiful. It'd look like a CRT. It'd have like the right level of blur, or at least close enough. And then I'd try to run it on my laptop, and it wouldn't work at all because my laptop did not support the right version of GLSL. And so instead, of course, I've got this hardware, this CPU-bound blurring that kind of makes it look right, but not really. But anyway, that is it right there. I would like to thank you for your patience with my blathering if you've made it this far. I'm going to link to a GitHub page that has some of the stuff I've worked on in the past, including this one. None of it is very impressive, but it is mine, so there you go. I plan on putting more converted GW Basic stuff on in the future. I just hit a point back in 2020 where I started getting more work again, and yada, yada, yada. So anyway, Thank you so much for watching. Take care.